We are comparing fractions and mixed numbers. It begins on page 80 here in chapter 2, section 2. We're going to start by defining least common denominator. And give me two fractions that have different denominators. Miles.
5 over 8 and 6 over 9.
5 over 8 and 6 over 9. Okay, so when we have two fractions like that with denominators that are not the same, what operation is difficult to do with these numbers when they don't have a common denominator? Mark? Addition, and the other one, Kyle? Subtraction. So we know, you know already that you've got to have a common denominator for addition and subtraction. The other thing is, look at the topic for today. We're comparing fractions. So when we compare 5/8 and 6/9, isn't that a little tricky too? Knowing really which one is larger or smaller, figuring that out. Some people have a really good sense of fractions and maybe could answer this question right now looking at those different denominators, but most people want to change them so that they have the common or the same denominator, right? And so we're going to talk about how we can do this. There's more than one way to do it, changing these fractions. But the least common denominator would be which denominator? Which one? Mark?
The least common denominator for these two would be 72.
Would be 72? Okay, so you're giving me the answer to this one, and how do you know it's 72?
Because when you multiply 8 times 9 and 9 times 8, you get the same number, which is 72.
So is that always the way to find the least common denominator?
No.
So we're going to talk about how you know whether that is. Who thinks that 72 is the least common one in this case? And who's a little bit uncertain whether it's the least one? Okay, a lot of people are uncertain. So we'll talk about how you will know whether you have the right one or not. The least common denominator is the least common multiple of the denominators. So you remember that from last year, finding least common multiples. So let's try it with this, and then we'll go back to that example and see if 72 is correct. So how do we find the least common multiple of 9 and 15? There are two methods. And the first is just listing multiples. The second is using prime factorization. So let's try both. And you, again, may use whichever one you think is good for a particular problem. Sometimes you can use this first method of listing multiples just in your head. When we list multiples, I like to put the original numbers down, kind of stacked up on top of each other like that. Okay, let's continue with the multiples. So multiples are a number you get when you, it says it right in the term, when you multiply. A multiple is what you get when you multiply. So you're not chopping the number up, okay? You are multiplying. So what is 9 times 1? 9. And we're using non-zero multiples. Because we could say 9 times 0, right? Okay. And what is 9 times 2?
18.
And we could continue. 9 times 3. This is how you do it. 9 times 4. 9 times 5. 9 times 6.
54.
Okay, let's just stop there. We can keep going, of course. Sometimes you have to. But that's the first 6 multiples of 9, non-zero multiples. So let's go with 15. 15 times 1 is?
15.
15 times 2 is?
30.
And as you're doing the second list, you're watching for any number that appeared in the first list. So what is the first number they could both become? So 15 times 3 then is?
45.
And ding, 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 there it is. Look at that. They both can become 45. Now, is 45 9 times 15? So sometimes people think that to find the least common multiple, we just multiply the two numbers together. But that's a much larger number, 9 times 15. What is 9 times 15? 9 times 10 is 90, and 9 times 5 is 45. So what's 90 and 45? 135. Good, I hear you saying it. So 135 is a multiple that they both could become, but it is not the least common one. We want to work with the smallest numbers we can work with. That way we don't have to reduce later. Okay? So there it is. The least common multiple of these two numbers is 45. But let's go try it with prime factorization too, just so we can understand that strategy. Sometimes it is faster than listing multiples. Okay? So for prime factorization, we place the numbers at the top of what becomes their factor tree, right? Luca.
But prime factorization might not exactly have every.
Okay, so we start to list the numbers. And tell me, Matthew, what makes up 9? Give me the factors. So 3 times 3. And it's called prime factorization because you stop factoring when you get to prime numbers. And so is there any way to factor 3 outside of it being prime? So is it a prime number? Yes. So sometimes I like to circle the prime number so you can really see it. And then we can write the list of factors that makes up 9 using exponents if they're needed, right? And so I see 2 factors of 3, so what's the shortest way we could write that with exponents? Michaela? 3 squared, so we can write it that way. There you go. Now we'll do the same with 15. What are the factors of 15, Brianna? 3 times 5, she says. Now are those prime numbers?
Yes.
So good. We stop there then, and there is 3 times 5. We can list out the factors. So now, when you have factored both numbers, you have to remember what you're going to use to find the LCM. And so what you're going to use is, look at here. 9 has 3. 15 also has 3 as a factor. So which factor shall we use? 3 squared or 3? Cooper? Good, we use the higher power. If they share a factor, we use the higher power of it. Okay? So our LCM will be 3 squared. And now let's look. 15 has a factor of 5. I don't see any other factors for 9. So shall we use it?
Yes.
We shall, yes. We have to use every factor. And so if 15 has that factor of 5, then we use it. We use every factor that is in either number. Only when they share a number do we take the higher one. Okay? So 3 squared times 5. And we know that 3 squared is 9, and 9 times 5 is, and we already knew that. That we know is the least common multiple for these two numbers. Okay? So you can write down the steps to finding LCM by factoring. Use every factor. If they share a factor, use the larger power. If they have the same power, just use it once. Okay? If they both had 3 squared, you would just use 1 3 squared. So 5/8 and 6/9. The question is, do 8 and 9 have any common factors? Who can give me the factored form of 8? Miles? 2 and 4, and then 4 is 2 times 2. So how many 2's are in 8? 3. So 2 to the 3rd, right? And then 9, everyone knows, is 3 squared. So do they have any factors in common? No. So since they don't have any factors in common, we're going to use all the factors. We're going to use 2 to the 3rd and 3 squared. So it ends up being 8 times 9, which is 72. It is the denominator that some of you thought it would be. Okay? Let's try it here. You may use either method. Okay, thumbs up if you have it. Oh, okay. So who's making a list? And who's factoring it? Ooh, most people are factoring it. That is awesome. Okay, since you're factoring it, I'll factor along as well. So give me the factors of 3. This is hard. Adrian? And so it's just 3, right? Because it is already prime. And now the factors of 8. Adrian, you want to tell us that?
Yeah, 2 and 4, and then 4 is what happens between and 2.
So when we write that, we would say 2 to the third, and this one we would write this as 3. So we would say the LCM of 3 and 8 is, this one has a 3, the other one doesn't. Do we use it? Do we use it?
Yeah.
Yes. 3 times. This one has 2 to the third, the other one has no 2's. Do we use it?
Yeah.
Yes. So we know that that is 8. 3 times 8 is
24.
24. So this is a case where the two numbers, 3 and 8, are relatively prime. They don't have any factors in common, and other than 1. And so we just multiply them together when they're relatively prime like that. Okay, so Kyle tells us 20. And sometimes, if you think of this in terms of the list, we have 4 and we have 20. So 20 times 1, 20 times 2, and we know that 4 can become 20. So sometimes we would go 4, 8, 12, 16, 20. You probably don't even make the list. In your mind, you know the smaller denominator could become the bigger one. So the bigger denominator is sometimes the least common denominator. It's the bigger one though, okay? And let's try comparing now. So we have 2 fractions, they're both negative, so watch out. And compare them and graph them on a number line. Okay? Okay, so Cooper noticed 3 and 14 are relatively prime. 14 doesn't have any factor of 3. So he says you just multiply them together to get the LCD. So what did you multiply 3 by to get to the 42? 14. So negative 1 times 14 is? Good. And then what did you multiply the 14 by to get to 42? 3. So negative 3 times 3 is? Negative 9. So there we have the 2 blown up fractions. And when we're asked to compare, we have 3 sign choices, right? Who can tell us the 3 sign choices? Luca.
Addition, subtraction.
Actually, those are operations. We need signs when we're comparing 2 things. You want to try, Matthew? He says greater than, less than, or equal to. Okay? So be careful because these are negative. So sometimes our world changes when we have negatives, right? Go ahead and try and graph them and put the correct sign. So these are negatives, so I'm going to put 0 way up here and start moving negative to the left like we would normally do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Negative 14 over 42. Each line is a 42nd. 1 42nd. Negative 1 over 42. Negative 2, 3, 4, 5. Negative 5 over 42. 6, 7, 8, 9, 10. Negative 10 over 42. So do you see how you can use whatever scale you want to use on your number line? And these are just each representing 1 42nd. So you can see the negative 14 42s. Make sure you plot it good. Negative 14 over 42. And then we have negative 9 over 42 over here. So number lines are fantastic. They show us from least to greatest, don't they? So who can give us the correct sign to place between these two? Here, Audrey. And so she says negative 14 is less than, and she's reading it left to right. Very good. Remember, when you read these signs, you have to read them left to right. So the little pointy side is pointing toward the negative 14, which is less than negative 9. Go ahead and try this. Come back and check your work. So we first tried a list, and it got so long we decided to factor. And we found the common denominator of 144. How does one compare mixed numbers? Jensen? I think this example is so basic that most people know which of these is greater. But if you need to, you could change it to improper. And so If you don't need to, because they both have the same denominator, there's no change needed. Which one is greater, Claire? Good, 2 and 3/4. You can say that, right? But here, this is a little trickier to know which is greater. So maybe this would be a good time to change both of them to the improper, right? So tell me, what is the right one as an improper? Skylar, can you tell us? Remember how to change that to an improper?
The 16.
This one, the mixed number. Times 3. Yes, so what is that? 3 times 3 is 9 plus 1 is 10. So she says this becomes 10, still being divided by 3. The left one is 16 over 5. So it's still tricky to compare them. And so what would the LCD be? Do you see that? Do they have any factors in common? Actually, both of these numbers are what kind of numbers? Prime. So they're definitely relatively prime. So we would simply do what, Matthew? The 15. Just multiply the 2 together and you know what the denominator is. And so can you tell us the numerators? And the other one's 50. So now it's pretty easy to see which one is greater, right? And the one that's greater is 50, right? So we can go back up and put the sign in correctly all the way to the top.